But where issues have come up is that they discovered that as the dead body continued to stay for some time, you find out that when you come, you find the larvae, when it eats enough food, it moves away from the corpse. And they discover there's a problem. And what they check and discover is that as it moves away from the corpse, it doesn't fit again. It will start to shrink. When it starts to shrink, then the issue of length is lost. Now, what is the solution? So researchers started digging. How do we find a solution to this? And that is part of what we had to do. So we had to come to the point of saying that, okay, if we have that, what do we do? What future can we use to be able to identify, to give a marker for aging the wandering stage? It's called the wandering stage of the larvae. And if you see here, we said the degeneration of its salivary gland is explored as a potential marker for the age of the wandering stage, looking at the cells of the salivary gland with a particular emphasis on the changing morphology of the nucleus and its polyethylene chromosomes. So what we simply do is a very simple experiment that we did. We use a temperature control room, because anywhere you're going to collect sample, you must get where you'll be able to get the temperature and the humidity of that environment. If you don't do that, it will not help you to give a very correct result. So we normal light microscope for us to be able to dissect the salivary gland. Well, we'll pick the larvae, we'll monitor it from when it is active and when it is moving. And then we'll dissect, we'll remove the salivary glands are in two pairs. We removed it. When you removed it, and this picking, we do it 24 hours. After 24 hours. Then we stained it with what is called propylium iodide. It's an iodide that stains nuclear materials. So when it stains the nuclear materials, it will be able to give you the nucleus of that salivary gland clearly. So that's what we did. And then we use confocal microscopy. Confocal microscopy is very expensive. But we know that for an ordinary forensic lab, if you have ordinary fluorescent microscope, you can run this. So confocal here is not, it should not be a hindrance for running this. So what we now did, when we stained it with the ethidium bromide, if you check here, we check the microscope, we check the slides under ×10. That's what we did here. Then we now increase the magnification to ×40, and we increase it to 63. And if you go on for, that is the first day, that's the most active stage of the salivary gland. Then on the second day, we did a similar thing too. We check it at 10, 40, and then 63. So if you check the shape here is slightly different from the shape here. And then as we now move to the third day, this is what we're getting. You can see the shape is changing. Then we now move to the fourth day, you can see what we have. And then when we now move to when it has formed pupa, because when it formed pupa, we'll still find the salivary gland. And we still got some pieces. You can see what we're having here. So this was what we were able to use. But we use room temperature. That's what we did here. And then we're able to monitor the relative humidity. So, but you can play around with it. We play around with it, but I'm just making one presentation. So, but what we did is we reduced the temperature, because this work was done in the UK. So we reduced the temperature up to 10 degrees to see, because depending on when situations will happen, at times it might happen during the winter. And if it happened during the winter, what do you do? So that's what we try to do to be able to age the wandering stage of the larvae of blue fly. So, it said here, the changing morphology of the nucleus revealed a predictable pattern from the active feeding stage through the wandering larva stage until mold into pupae. Therefore, it has been recognized as a very good marker for aging the wandering larvae of the blue fly Calliphora Vicina, which can be used to estimate post-mortem interval of older corpses. TEDFON, then it was ETF that sponsored me to go and carry out the analysis. And then thank you for listening.
Thank you very much, Doctor. Do we have any question for him? Okay.
Thank you very much, the presenter, sir. I think the lecture was very brief and interesting, very interesting. My question goes thus. I'm DSP Sunday, forensic staff, Nigerian Police Force. My question is this. If we delay the recovery of the larva, does the quality of morphologies recovered from the scene still be considered under that temperature or not? The morphologies, the quality, yes, of the sample you get, if being delayed beyond expectation, do we still consider the temperature of the environment?
If you delay in collecting the sample.
Yes, sir.
If you
If
delay,
there's delay in collection of the sample
yes,
at that scene,
yes,
do we still consider the temperature of the environment?
Funny enough, what we did, we extended to the pupa stage of this fly. Okay. That was what we did, because we expect that there are times that when you want to take samples, you might come and you discover it's a pupae. It has changed to pupae. It's no more larvae any longer. So how do you age it? We already have that too. So, but the time you are coming to take your sample, that is the time you check the temperature. But normally it's a range. You check it 2 days after, 2 days before, like that. So you just take that temperature. It's just to guide in the result. So, but it's not that. It's just to tell you that, okay, I'm working within this temperature, So it helps any investigator or any lawyer to understand what you are doing. Because it's expected that there is a station somewhere, a weather station not far from where you collected the samples.
Thank you very much, Doctor, for that exciting presentation.
Thank you, sir.
I was eager to hear more,
Okay.
on this, because it's a very new thing to me. Because I think it's for post-mortem studies.
Yes, sir.
And from that point, what do you do? Because I was eager to hear the next step. That once you get to know the changes in the larva, then how do you now use it to know what has happened?
Yes. What you do when you now have this, it will be able, if you check, it used to be that what actually used to happen is after they have established the immature stage, they now jump the wandering stage and went to pupa straight. And in the pupa state, they were struggling because the pupa is a stationary body. It's not feeding. And then when you look at it, you say, oh, is it the color of the pupa that we use? By the time you check, you get to a point you cannot differentiate it. So they had to start looking for solution. I presented 2 of the papers so that they will go together. So, but they gave me room for 1. Exactly. So, but actually, at that stage, like what we are using here, we will now have this in the, they will now have it like a marker. So by the time they now collect, they go to a crime scene, remove the larvae. By the time they check, they'll just come quickly and then cross-check it with what we have. And that's what they do with the length of the larvae, because they already have a standard length for each day. So by the time they come and then they check, they will now say, okay, it's 5 days from when the person died. So from there, what they usually do is that they will now go back and say, oh, who was he with that day? Who was he with? Even that day, 5 hours, 7 hours, 10 hours, those are the people they will now bring as suspects to the court of law. So by the time they bring that evidence, they will be able to know, oh, we have checked this. This person died this day. And you were with him on that day. What happened? So from there, and then with other scientists, because the forensic science don't work alone. What the entomologist is bringing is just one aspect. The DNA person is bringing is another aspect. Because it's something that will now prompt the DNA person to go and start searching and pick whatever little evidence he will be able to pick. And all other forensic scientists too will be working to see. My supervisor now is working on mites. And then what he discovered is that if I hit you, the mite in my own clothes will now drop on you. And they will be looking for that mite on the dead body to compare. If they are able to know that I was with him, they will come back to me and collect my mite and compare it to the one he has. That is how deep they have gone in the UK.
So my question is this. What if the person died in a very, very cold weather, like freezing ice? Is it still possible to get this larva?
Yes, ma'am. They have found some corpses in freezers, and they discover it.